Here we talk about the geometric interpretation of linearly independent and linearly dependent. So suppose we are talking about two vectors in R2. So here's a R2 space, and we have two vectors, say V1 and V2. So linearly independent say that these two vectors are on different lines. And in this case they are linearly dependent. These two vectors are on the same line. One way we can think about that is this. We always start by a linear combination, say C1 of times V1, C2 times V2 equal to vector 0, right? Vector 0. And if this system has only the trivial solution, C1, C2, right? I can write this. C1, C2 equal to vector 0, right? 0, 0. Then this is linearly, these two vectors are linearly independent. And if they exist or has a non-trivial solution, we'll just say that now we have the solution C1, C2 is not just the trivial one, 0, 0, right? So in this case, either C1 is different from 0 or 0 different from 0, or both different from 0, right? Or maybe both of them. So suppose that I can suppose that C1 different from 0. So first let's conclude this case they are linearly dependent. Then assume that C1 different from 0. Otherwise you can assume if C1 is 0, then we can assume C2 is different from 0, right? Then we have V1 is just C2 over C1 V1 V2, right? From here. So C2 times V2 equal minus C1 V1, right? V1 equal to this one over minus C. So minus C2 V2. So that means that this vector V1 is something, a scalar times V2. Right? They are on the same line. This is one way to think about that. We can also do that with three vectors in R3.